Assalamualaikum and selamat sejahtera to our beloved Madam Eliana. Today we would like to present about Quadrature Amplitude Modulation for subject BEET 2333 Communication Principle. Next, I would like to introduce my group members, which is first is me, Nur Ashiki binti Muhammad Nasir. The second one is Wajihah binti Kamaruddin. The third one is Muhammad Syazwan bin Saleh. The second last is Muhammad Izzat Syahmi bin Muhammad Nazli, and the last one is Muhammad Akmal Aidil.
Assalamualaikum and hi. My name is Muhammad Syazwan bin Saleh. My matrix number is B0821103999. And I'm from Group 5. Our title for this task is Quadrature Amplitude Modulation, or QAM. And my part, I will explain a little bit about QAM. So the introduction for QAM is a modulation. QAM is a modulation technique widely used in digital communication systems to transmit digital data over radio waves or wired channels. It combines both amplitude and phase modulation to efficiently transmit multiple bits of information in a single symbol. And next, the signal of QAM in which two carriers shifted. The signal of the QAM is two carriers shifted in phase 90 degrees, sine and cosine. So basically it two carriers shifted. That is the signal for QAM. And the third one, the resultant overall signal consisting of the combination of both I and Q carriers contains. And for more detail, my other groupmate will explain more. Thank you.
I will explain type of modulation technique. There is two types of modulation technique, which is analog and digital. Analog is typically used to allow multiple analog signal to be carried on a signal carrier. For digital is used for radio communication application, which is able to carry higher data rate than ordinary amplitude modulated schemes and phase modulated schemes. So for this quadrature amplitude modulation, we use digital modulation technique. Digital QAM are generally described as a quantized QAM and used in radio dispatch system ranging from cellular technology to Wi-Fi. Digital QAM can carry advanced data rate compared to both amplitude and phase modulated scheme. This picture below shows the waveform are indicating the two different carrier signal of the QAM technique for carrier 1 and carrier 2, and the next picture is the output waveform of QAM after the two carrier were combined.
Assalamualaikum to Madam Eliana. My name is Wajihah binti Kamaruddin. Today I will continue present about the advantage and disadvantage for digital modulation technique. For the advantage, it will increase the efficiency of transmission for radio and communication system by utilizing both amplitude and phase variation. For the disadvantage, firstly, it will more susceptible to noise because the states are closer together. Second, level of noise is needed to move the signal to a different decision. So next, I will present about the QAM constellation diagram. So for the QAM, What is a QAM constellation diagram? It is a graphical representation of a QAM signal. It shows the amplitude and phase of the signal to each point in time, allowing for precise analysis and manipulation of the signal. In digital communication, QAM constellation diagrams are used to encode and decode data, making them an essential tool for transmitting information over long distance. To create a QAM constellation diagram, the signal is split into parts, which is the in-phase component and the quadrature component. So this component are then plotted on two dimensional plane with the in-phase component on the x-axis, while the quadrate component on the y-axis. Each point on the diagram represents a unique combination of amplitude and phase, which can be used to represent a specific set of data. By analyzing the location on these points, it is possible to extract and interpret the data being transmitted. So, how QAM works? QAM stands for Quadrature Amplitude Modulation, which is a modulation technique used in digital communication to transmit data over radio waves. So for the conclusion, QAM constellation diagram are an essential tool in digital communication. They allow for increased data transmission rates and improved signal quality, making them a valuable asset in various industries such as telecommunication and broadcasting. So it is important to continue exploring and researching this topic to future improve our digital communication systems. That's all from me. Thank you.
Wabarakatuh. My name is Muhammad Akmal Osman. Matric B082110071. Today I will show our circuit with QAM modulate. We use a random integer. So the function of a random integer is to uniformly generate random distributed integer that is based on the set and size parameter. Next, we have a rectangular QAM modulator baseband. So the function is to modulate the input signal that is generated from the random integer. The data that is generated from the random integer generate carry to carry signal that is shift in phase by 90 degree in sine or sine and cos cosine wave, where they are both combined, where one signal is called the in-phase signal or I signal, and the other one is quadratic signal or Q signal. So the new signal that generate from that is produced from rectangular QAM and will contain both amplitude and phase variation. After that, we use a AWGN channel or a white loss noise channel. It is basic noise model to imitate effect of random processes that occur initially based on the parameter that we insert. So we will use using the rectangular. Next, we will using the 16 km rectangular KM demulative baseband. So the function of this 60 km demulator is the opposite of rectangular KM modulator baseband. It will revert the signal of the QAM modulator. The signal will then be split and applied to mixer where the signal will be modulated and returned, the same or similar to the input signal. Then we will see the view constellation of 16 km for the rectangular km modulator basement. And now for the constellation diagram, we will see right here. So as you can see here, this is the same as the previous constellation. As you can see a 10 bit, as you can see for the yellow one, which it has 10 bit for each symbol. And then for the scope, which is we got the signal. So this is the input, which random integer that we get that we got when they let the integer and demulate, since it demulate by the previous modulator. So the waveform will always the same. For the input and the system from the and now we see the modulation. So this is the second this is the input, and then for the second one is this system modulator here, which is we use to find the rectangular modular displacement, which we write here. And this one for the generate for real and imaginary waveform. And now we use we set the sine wave, the same one. That's all for me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Izzat Syahmi Muhammad Nazli. My matrix number B0821103880. So, I'm going to talk about the summary of this assignment. So, at the end of this topic, that we will learn is about QAM, Quadrature Amplitude Modulation, combines amplitude and phase change to give additional capacity and is widely used for data communication. If its modulation increase and the number of points on constellation diagram is also increased, so QAM can be a modulator and demodulator. That's all from me. Thank you.